here we are in chapter 2, and this is going to be the start of introducing proofs to you, which a lot of geometry is. So in the first 2.1, we're learning about patterns and inductive reasoning. So we're going to talk about what inductive reasoning is and what conjectures are. First, inductive reasoning is the reasoning based on patterns you observe. So anything that you have seen throughout your life, and then you know the same thing's going to happen over and over again, that's like inductive reasoning. If you live in Minnesota, you know that after winter comes spring, then summer, then fall, and it has that pattern. If you do not live in Minnesota and you live closer to the equator, you might not know of that pattern that's further north because you have never seen it before. So inductive reasoning is things you have seen or observed. So we can use our inductive reasoning to look for the next two terms of each sequence. When you're doing this, if I look at my first terms, I can see that from 3 to 9, that'd be like adding 6. So I want to test this, make sure that that's going to fit for everything. So is 9 plus 6 equal to 27? No, that doesn't work. So I'm going to have to try to find something else that might work. So I also know that from 3 to 9, I can multiply 3. So 9 times 3, is that 27? Yes. 27 times 3, is that 81? Yes. So I'm using my inductive reasoning to know that the pattern is multiply by 3. So I'd want to multiply 81 by 3, which is 243. That's one term, but it's asking for two terms. So then I want to multiply that by 3, which would be 729. So those would be my two answers. Now if I look at the next pattern, well, first thing I notice is that each one of these 3 shapes all begin with a circle. So I'm going to make 2 circles. These are hand-drawn, so yes, they do not look like circles. And now I have to figure out what should go inside the circle. So if I look at the first one, that's a triangle that has 3 sides. And then it's a square that has 4 sides. Then it's a pentagon that has 5 sides. So I'm guessing my next 2 should have 6, then 7. Now again, this is going to be hand-drawn, so bear with me. So 1, 2, 3, 4, 5, 6. That's terrible. But that should have 6 sides and then 7 sides. 1, 2, 3, 4, 5, 6, 7. That doesn't look the neatest, but since I wrote down below how many sides it should have, that would be perfect enough work for me. Right now I want you to pause and try to figure out the next 2 terms of each figure or each pattern. So if you look at the first pattern, again, I tried to add 4 each time and that didn't work, so I crossed that out. Then I noticed 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that's my pattern. So my next 2 terms would be 64 and 128. On the next pattern, first I tried to add 3, and that didn't work. As you can see, I wrote how many total boxes were in each square below, because that could help you. So in the first box, there's 1. Second box, there's 4. Next box, there's 16. So I notice I'm multiplying by 4 each time. So in this next box, there should be 56 boxes, but I'm not going to draw out 56 boxes, so I'm just going to be labeling 56. And then I multiply that by 4, and again, if I didn't draw out 56 boxes, I'm not going to draw out 224 boxes. So that would be my next 2 patterns. Once you find a pattern, you can find a conjecture, which is a conclusion you reach using inductive reasoning. So after you figure out a pattern, you can make a conjecture. So this is kind of like the same problem, except it's asking what's the conjecture you can make about number of regions 20 diameters form. So if I look at this, I'm going to label this my first term, second term, third term. I'm trying to get up to how many spots will be after 20 terms. So my first term, there's 2 spots. In my second term, there's 4 spots. In my third term, there's 6 spots. So it looks to me that I'm counting by 2, because my next circle would have 8 spots in it, and then I would have 10 spots, and that would be my 4th and 5th term. Now if I look at my terms and the number of sections I have, I can see that another way to think about this, the term is being multiplied by 2. That's why I got 2 below. The term for a second is multiplied by 2, and I get 4. So if I want to figure out how many spots or sections would be in my 20th term, I could say in my 20th spot, or 20th term, there are 40 regions. So I would use a pizza slicer and cut them out into 40 different slices. Those are pretty thin. In this next problem, it's asking what conjecture can you make about the 21st term? So if I'm looking at the pattern, I can see it goes RWB, 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 RWB. So I have 3 letters that repeat and repeat and repeat. And I'm looking for the 21st term. I'm quite fine with you writing out the 21 terms and then saying which letter it is. However, since I know that it's a multiple of 3, if my term that I'm looking for is a multiple of 3, then I can just say that the last letter would be B. Because this is my first term, this is my second term, and third term. So all of the multiples of 3 that can fit into 21 would be B. Let's say if I was looking for my 26th term, I could say that 3 times 8 is equal to 24, and anything that's a multiple of 3 has the letter B because it's the third term, but now I need 2 more terms after that. So if my 24th term is B, then my 25th term would be R, and my 26th term would be W. My 26th term would be W. I know this may seem confusing right now, but we will be practicing this a lot in class. So make sure if you don't understand something to write down the problem and ask questions in class. Right now you should pause and read over this problem. So what this is asking is how many backpacks are being sold in May. Now I'm going to use the graph to help me solve this problem. First, how do I read a graph? Whenever you see something like this, that's saying it skipped from 0 to 8,000. So I'm counting by 500s. Each of these boxes are worth 500, but I didn't want to start at 0 and go all the way to 500 or 1100 if I wasn't going to use all those numbers. So if I look at this pattern, it looks like it's decreasing. So if I were to plot the point of where it might be for May, I would say it would be about there, except it would be on the line. And so if I want to say what would that be, looks like if this line is 8,000, it would be just below 8,000. So I might say 7,850 backpacks. If you were going to be solving this and get a different answer, that's fine, because it's just taking the graph and looking what can you say, what conjecture, what rule could you say about the graph. And the last thing we're going over today is a counter example. Counter example is just showing something that makes it false or incorrect. So these are 2 conjectures that could be made, but I want to prove them false, so I want to find a counterexample or something that would make them false. So the first one says, if the name of a month starts with J, it's a summer month. So that would be like June and July. Well, that makes sense. That's true. So now I want to think back, are there any months that are not in summer that begin with J. And I could say January would be that counterexample. That would make that conjecture false. The second one says you can draw any 3 points to form a triangle. Well, that makes sense. If I were to draw 3 points right here, there's 3 points and they form a triangle once I connect them. So now I have to think, how can I draw 3 points that would not form a triangle? So first I'm going to just start off with 2 points. Now where could I put the third point so it's not a triangle? Well, I know that if 3 points are on a line, then they can't form a triangle. So those 3 points are collinear, and there's 3 points, but they're not forming a triangle. So that would be another counter example. Right now, you should pause the video and try to find 2 counter examples for the next 2 problems. When you multiply a number by 2, the product is greater than the original number. So if I think about this, any number multiplied by 2 is going to be larger than the original number. So let's say if 2 times 2, well, the answer is bigger than my original. So that makes that true. So I have to think of something else. Well, let's see if I do negatives. If I have 2 times negative 2, that's negative 4. Negative 4 is not greater than negative 2, so this would be a good counterexample. Other counterexamples that you could have had would be 2 times 1, because my answer is 2, which is not greater than 1, or anything less than 1 would actually work. My next problem says, when you multiply a number by 3, it's divisible by 6. So I have to figure out a number that can be multiplied by 3 but cannot be divided by 6. So let's see if I do 3 times 2, that's equal to 6. That's not a counterexample because that's true. I can divide 6 by 6. So then I'm going to try 3 times 3. That's equal to 9. That is not divisible by 6, so this would be a great counterexample. Something that makes this false. So again, counterexamples make this false. That concludes our 2.1 lesson. If you have questions, make sure you note them in your notebook and ask tomorrow in class. The only dumb questions are the ones that are not asked. Have a wonderful day. See you in class.